All right, guys. So when you hear combined like terms, what does that mean to you guys? I know you guys have heard this term probably seventh, eighth, um, now in ninth grade. Again, you're going to do this all throughout your guys' math careers. What does it mean to combine like terms? Now, whenever you hear combine like terms, what you're really doing is you're pretty much deciding whether to add two things. Now, let's start with something super straightforward and simple. Something like the number 5. And let's say I want to add it to another number 4. Now, notice here that you are adding two different things. Those things are what we're going to start calling terms, and I'll put a little bit more definition on it tomorrow. But notice here you have a term plus another term. Can you add these terms? Can you actually mathematically take 5 and add 4 to it? Yeah, because you could simplify it and then it would equal a 9. Now, what allowed you to add those two numbers? Well, they were like terms. Now, of course, when you're thinking of numbers, it's pretty straightforward. Let's go ahead and add variables to it. Let's say I have an A, and I want to add another A to it. Now, can you add an A to an A? Yeah. And the main reason why is the way I like to think about it is like, okay, if A stands for an apple, and I want to add another apple to it, how many apples do you have? 2 apples. Absolutely right. Now, what allowed you to add these two variables together? Because again, they were like terms. Now, let me show you the biggest mistake that students make, especially because we just went over rules of exponents. They'll see A plus A, and they'll be like, okay, that's an A squared. But what did they do wrong? They applied the rules of exponents. The rules of exponents state that if you multiply two like bases, you add their exponents. But are we multiplying like bases here? No, we're adding them. So keep in mind, do not be this person over here. Now let's dive a little bit deeper into combining like terms. Let's say that I have a variable A, and I want to add it to a variable B. Can you add an A to B? No, right? Because the way I like to think of this is, okay, A is an apple, B is a berry. Can you add apples and berries together? No. So what do? Well, whenever you want to simplify these, you just have to rewrite it and tell the reader, hey man, there's nothing that you can do to add these, so I'm just going to tell you, hey, add the A and the B together. Now let's say I have a variable like A, and I'm trying to add it to a number. Are these considered like terms? What do you think? This is an apple, this is a number 5. Do you know what this number 5 technically is? Can you technically assume that it's an apple? No, right? It's just a number, and this is an apple, so you cannot add those two as well. So you would have to rewrite it over. Now, last but not least, let's do this last one. Notice you have an A squared plus an A. Can you combine an A squared plus an A? They're the same variables, but are they the same things? What do you guys think? No. Now, this is the reason why. Notice you have A squared plus an A. This is what I like to do, remember, is that you have an apple squared. An apple squared isn't the same thing as just an apple. There's something different to it. So you end up with something, or you end up with nothing different. They're just going to be rewritten over. And one way you could think about this, if you have two things like, I don't know, let's say 2 squared plus 2. Are these like terms? No, because notice that 2 squared is technically another number that you have to perform an operation on at first. What is 2 squared? 4. So you can't, technically with their numbers, right, you could add the 4 and the 2, but as it stands, those are not like terms. You cannot add them. Pretty much the moral of the story, in order to add two terms, they have to have the exact same variables with the exact same exponents. So, of course, that's kind of the basics. Let's go ahead and start doing the problems that we need to cover for today, which are going to be a little bit more messier, and you'll see. So today all we're doing is simplifying by adding two different things. Now notice here that they're going to give it to you in two parentheses, and the parentheses are just there to show you, hey, add this plus this. Now the number one thing you have to remember when you see problems like this is ask yourself, is there anything to distribute in front of those parentheses? Now if you look at these parentheses, is there anything to distribute? No. So I'm just going to rewrite it over as 5p plus p to the 4th power. Now, is there anything to add in front of these parentheses? No. So I'm just going to rewrite it over. Now, keep in mind that if you were to distribute that positive, everything would remain the same. So I'm just going to drop it, just kind of knowing that, because in the future we're going to subtract them and so forth. So that's what's we have to look forward to. Now, looking at all these terms, notice that these is this, plus this, plus this, plus this. Your job is to simplify. So pretty much add what you can add and don't add what you can't. Now, what I like to do is I like to start with my first term that shows up. Notice it's a 5p. You have 5 whatever p is. It could be a pair if you want to think of it that way. Is there any other terms that have a single p? The answer is yes, because if you look at that negative 2p, it's just a negative 2p. So these are what are considered like terms. You can combine them. Now that's a 5p minus 2p. Now if I have 5 pairs minus 2 pairs, you end up with 3 pairs. So just to reiterate, what I like to do is I like to concentrate on one term at a time. I go through each and every single term and see if I can add them. If I can, I circle them, and then after I'm done actually simplifying them, I cross them out, because again, it helps for organizational purposes, because later on you'll see that they get pretty long and big. So with this being said, notice you have a p to the 4. Is there any other p to the 4s? And the answer is yes. You have 2p to the 4s. So a p to the 4 plus 2p to the 4, how many p to the 4s are you going to have in total? 3p to the 4s, right? Because if you're like me, I'm super visual. I'm going to write a little 1 there to kind of remind me, hey man, this is 1p to the 4. You have 1 there. So 1 plus 2 is 3. Now keep in mind that order does matter when solving these problems. Mathematically, it is proper to always have the biggest exponents first. So notice here that this exponent technically has an exponent of 1. This one has an exponent of 4. So the one with the 4 has to go first, and pretty much your exponents have to go from greatest to the least. And that's it. Okay. All right, so let's try number 2 together here. Notice that I'm adding 2 terms here. Is there anything to add? Or is there anything to distribute in front of these parentheses? No, right? So let's go ahead and just rewrite it to kind of get those parentheses out of the way and out of sight, so that way I know what terms I could add. Now notice that these parentheses do have something in front, but it's a positive. If you were to distribute a positive, you'd end up with the same thing. So kind of just to save time, I'm going to train my mind just that if I see a positive in front of parentheses, I'm just going to drop the parentheses because there's nothing really to distribute. Now notice that I have 4 different terms. You can only combine the terms that have the exact same variable with the exact same exponent. Now, just to be a little more purposeful, I know I have to line up my terms in terms of greatest exponent to least exponent. So this time, instead of just starting with my first one, I'm going to automatically look for the biggest exponent. And I can see here that positive 3r squared is my first. And then I'm going to just look to combine everything that's r squared. Now notice you have a positive 4r squared there. Now 3r squared plus 4r squared is 7r squared. Now just go on and figure out the next one. Now I notice I had an exponent of 2, so I'm going to look for exponent of 1s. Now notice that here I have a 5r and a 2r. Now what is a 5r plus a 2r? 7r. So if you kind of play it correctly and you look for the biggest exponents, you can avoid the whole rearranging, and it helps you pretty much make less mistakes. So that's what I do. I kind of start with, okay, what's my biggest exponent? Let me combine those. And let me go 1 exponent down, combine those, and so forth until I'm done. Biggest suggestion I could do is make sure you cross them out as you go on, because so many students, especially when you'll notice here, the problems get bigger and messier. And it's your job to figure out what to do and make sure you're organized. So keep doing that if you're struggling and you're missing values. So try these 3 and 4. I'll go walking around seeing if there's anything I could help or clarify or anything like that. Track. All right, so if I look at this first one, which is number 3 here, notice that I have nothing to distribute in front of these parentheses. So what I'm going to do is just rewrite it over, and then I'm going to look at my second one, and I notice that I'm adding all these other things. So I'm just going to drop those parentheses. Again, what allows me to drop those parentheses? The main thing is the positive out in front, right? If there was something like a 2, a 3, or a negative, you would have to distribute it. But if it's positive, it's just going to remain the same. So one thing, if you are one of those people that rewrite it, make sure you rewrite everything correctly. There was another class where I rewrote it twice wrong, which I double-checked. It's okay. Now, looking at all these terms, I notice that 3 is my biggest exponent. I have an x to the 3 there, and I have a x to the 3 there. So remember, when you're combining, what you're really doing is just adding. So what is a 3 minus or plus a negative 4? Well, what's 3 minus 4? A negative 1. X to the third. Don't forget that your exponents and your variables don't change. Now we have all our thirds down. Let's see if we have any squares. Now, do we have any squares here?
Hi. No, Matt. Oh, there it is, right there.
Thank you. So is there any x squareds anywhere here? No, right? I notice I don't have any x squareds. Let me look for the x's. Now notice I have a negative x there. I have a positive 4x there. So I'm a visual person, so I like to put that 1 there. And what's a negative 1 plus a positive 4? Positive 3x, right? These are now simplified, so I'm going to cross them out. I notice that now that I've crossed out everything, I have a negative 2 here and a negative 3. If I were to add a negative 2 plus a negative 3, you'd end up with a negative 5. So notice now, again, because I purposely went from my greatest to my least exponents in terms of combining, that I am set forward there. I have nothing to worry about. All right, let's see this guy over here. Nothing distributed in front of those parentheses, so I'm just going to rewrite it. There is a positive, but again, I'm not going to worry about it because they're the exact same thing. Or when you add, you end up with the exact same thing. Now, I can see here right away that these r to the 3's are my biggest exponents. So I'm going to combine those first. This is a negative 5 plus a negative 5, which would end up being a negative 10. Don't forget your r to the 3's. Now remember, that's an r to the 3, so I should be looking for r to the 2's now. Now, where there are an r to the 2, there's one there, but there's not any left. So I'm not going to let that scare me. I'm just going to rewrite it over because, again, you're just adding it. You're not going to just, unfortunately, this time it's just kind of like a pig. There's nothing really to combine. And then I can see here that I have 6 minus 5, and 6 minus 5 is just a positive 1. When you have a positive 1, you're adding 1. And that's it. Okay? All right, check out numbers 7 and 8. What do you notice about this one that's different than all the ones that we've done before? What are we doing now? There we go, we're subtracting them. So nothing really changes in terms of combining like terms and our overall goal, which is to just simplify. We're just going to this time be a little more purposeful with that negative. So is there anything distributed in front of these parentheses? The answer is no, right? Because there's nothing out in front of those parentheses. Now, is there anything distributed in front of these parentheses? Yes, because you have a negative. So keep in mind that when you're minusing something, what you're really doing is just changing the signs to it. So let's go ahead and distribute this negative, and let's be careful. A negative times a positive 5 is a negative 5x cubed. A negative times a positive 2 is a negative 2x to the 4th. So this one's more of a just to watch out. Keep a lookout for those negatives. Make sure you're distributing. And then you just do the exact same things as before. Now you can really ignore that subtraction. You're doing everything the same. Now looking at all these exponents, I see the biggest one's an x to the 4, a negative 2x to the 4. Is there any other x to the 4s? No, so I'm just going to rewrite it over. Now I notice I have an x to the 3 here. Is there another x to the 3? Yes. I'm going to write that 1 there so it's visually there for me. And that's 1 plus a negative 5. What's 1 minus 5? Negative 4, x to the 3rd, exactly right. Cross those out. Notice I have a positive 8x. There's nothing else to do, so I'm just going to rewrite it over. Yeah, I kind of got confused there too because I'm like, is that a negative or a positive? And then I just double checked. I just wrote it down. So that was my mistake too. I should have been a little more clear there. So how do you feel about this? Okay. All right. Now I'm going to just save time and I'll do number 8. And let's go ahead and do a kind of monster problem just to show you that you're really just doing the same thing over and over again. So if you look at something at number 11, it looks pretty intimidating, right? Notice that not only do you have 2 things, you have 3 things that are going on. You have something minus something else. But just like I always suggest, don't let something that you don't know get in the way of what you do know. And what do you know about this? That in order to simplify these, you can only combine like terms. That means that they have to have the exact same variable with the exact same exponent. Now, is there anything to distribute in front of these parentheses? No, so you're just going to rewrite it over. in preparation of finding what terms you can combine. Now, is there anything distributed in front of these parentheses? Yeah, you have a negative. So let's go ahead and distribute. Let's make sure that we take our time. A negative times positive is a negative, which I did correctly. A negative times a negative is a positive, which gives me that positive 1. Now let me go ahead and distribute this negative. You end up with a negative 3n squared minus 1. Now, yes, there's a lot of things here, but if you take it step by step, you're going to be just fine. Now let me go ahead and underline all my terms, and let me just look for the biggest exponent, which I see is the third power, right? A negative 6 n to the third minus a 5 n to the third, or negative 6 plus a negative 5 is a negative 11 n to the third. Now I just did a third power. Let me look for second powers. Now this is a positive 3n squared, negative 3n squared. What is 3 minus 3? 0. Now what a lot of students make the biggest mistake is they'll be like, oh, it's just 0, so it's just an n squared. But if you were to write down an n squared, what is the leading coefficient there? A 1. So you have to be careful to not be one of those students. Remember that if you subtract something and you end up with nothing, you have nothing. So no need to even worry about it. Just cross them out and just go from the next one. And you'll notice that when you go to the next ones, you only have constants, and you see you have a 1 minus 1. And what's 1 minus 1? 0. So these also subtract out. Notice that not technically, that's your answer, because there's nothing else to combine. You simplified it, and that's about it. Okay.